My name is Stephan. I'm going into my junior year at the Urban School of San Francisco. And this year is my second year at Blue Stamp. So I kind of took it a step further and looked at more of the business side of engineering. So I'll be presenting that a little bit later. But the device I created was a stabilization gimbal that people would be able to use with cameras. So what it is it's a device where you have a sensor on the bottom here that measures, it's an IMU, so an inertial measurement unit, which is able to measure where it is in space and time and where it could possibly be going. So inside of that it has an accelerometer and a gyroscope to measure where the angle is at and also the speed it's moving. So that is on the bottom, and then directly connected to that, it's connected to this controller. And on that controller is a code that I wrote and modified. And then on this computer here, I'm using a GUI, which is a type of software where you're able to change the PID settings, the pulses that are sent to the pitch and the roll motors. So the PID settings, kind of as Duncan talked about, uses calculus. So what happens is, if I was holding this and I holding it back here and I tilted it forward, the minor movement of me tilting it forward would send a signal to the IMU. The IMU would send a signal and send certain values to the controller, and the controller running on the software and also with the code on it would interpret those values, and then through that interpretation would send certain pulses to the pitch and the roll motors to try and keep the platform that this battery's on, try to keep it level. So here's kind of a demonstration. There's certain settings that I'm going to need to keep modifying further, but as you can see, if I move it forward, the battery stays level, and as I move it backwards, it stays level, as well as for the other axis. As I turn it, it stays level, and I can bring it back. So I guess it's kind of two axis. So if I was kind of moving forward, maybe I could add another axis to stabilize it further. But ultimately, my goal coming into this was to create a device that would be able to stabilize kind of anything. And you can see this direct application to people who suffer with Parkinson's disease. I know there are certain companies out there who have created devices specifically for eating utensils for those who suffer with Parkinson's disease. So this is pretty similar to that, where it's able to predict the movement of the patient, and through that makes eating, I guess, more comfortable. And then I created a presentation. So if I was to start a business, kind of directly, as I said, a second year student, if I was to create a business and go into the market, I took some steps, created a PowerPoint presentation about what that would look like in kind of a organized manner. So specifically, I figured if I was to go into the market, I think, and create a medical device for those who do suffer with Parkinson's, that's kind of the path that I chose. So the mission statement I created was providing a stabilization device, which you can see here, to create directly related to those who suffer with Parkinson's disease, who have occasional tremors, to make a device that their lives are taken a step further and their lives are made easier. So this is kind of as I talked about the technical specifications. So you have the power supply here is a 7.2 volts, you can see in the corner. Ultimately that would be a battery, but that gives power to the IMU, which is a little thing on the bottom here, where it measures its space and time. Then those values from the IMU are translated to the controller, which runs on the code that was uploaded to it, which can be modified using the software that's on the computer. And those are in constant feedback with the pitch and the roll motors to see if I move this motor, 3 degrees, how does that affect it? How does that move? And that was one of the larger problems that I faced in this was if I move it forward 1 degree, the motors then respond by moving it backwards, and then by that movement backwards, the accelerometer senses that it's going to keep moving backwards, and to fix that, it moves forwards. So you end up getting kind of a constant gray area where it's kind of twitching a little bit. So that's something that in the future I'd want to clear out. But so if this would be kind of the target audience, you can see the direct correlation with videographers or photographers. But then again, you also have those who suffer with Parkinson's, those who are like eating, aren't able to eat soup or something like that, and then all of a sudden using a stabilization device, their habits are made easier. So some barriers for entry, entering the market. You have, first of all, something that's important is you need to understand the market, understand what people need, and understand how you can directly cater to those needs or wants. So for those who suffer with Parkinson's, as I stated earlier, sometimes eating can be embarrassing because you end up spilling all over yourself. How do you cater to that? Is you create a device which makes that task, that simple task, made easier. So and then also understanding intellectual property. So understanding what a simplistic design means, creating something that's elegant, and something that can be, I don't know, not something that's embarrassing to use, but something that is something that people will use in their everyday lives. And then also how to protect your idea. Most people do it with patents, but there's also a certain part that you patent and a certain part that's kind of an internal secret that you keep. So maybe the code I use is something I keep secret while I patent a specific design, or how the motors interact with the IMU of the software. And then competitive advantages. So if I was to enter the market, you can see here that it's a pretty simple device, but so that simplicity does make it easier for the consumer to use, makes it easier for like presentability, and then also if something was to go wrong, if something like was to break because of the lack of materials, but still you have a useful product, you're able to, so like if a motor was to break because of the lack of materials, you'd be easily be able to kind of switch a motor out. Then also cost, kind of by using simplistic materials and creating a simple and elegant design, you're able to reduce the cost, which makes it affordable to a vast majority of people. And then also just creating a device that works and does achieve its intended goal. And then so, yes, there is competition out there. You see kind of professional grade camera gimbals for the photography world, and then also there are some devices or utensils for those who suffer with Parkinson's that already do exist. But the problem is there are many flaws with these companies. For creating professional devices, they're often too expensive when you end up having to invest thousands of dollars for a device that solely is a camera gimbal, where it solely is something that stabilizes videos. So, and you spend a mass amount of money, and you end up kind of only getting one purpose out of that. And you also have like a quality range where you don't know what you're really investing in. So you could invest $10,000 in a professional grade gimbal, but you don't really know if you need that. Where you can get maybe a $100 gimbal that works, gets the same point across. And also just the single application where you have a gimbal that only does one thing, or you have a utensil that only does one thing. So. Next steps. So taking steps into the future, I kind of put the claim out there. If I was to enter the market, maybe I'd need $1 million. Okay, a lot of money, but I believe that's what I need to produce this, create a prototype, design it, create a more elegant design, and then also add on to improvements. So you add on, make it more compact, like you see down here, if you're using a camera, but also kind of taking it a step further, and understanding how to take it a step further, and also creating a team that takes it a step further with you. So what does the final product look like? It's something that's elegant and something that's reliable that will ultimately change someone's life for the better. So, thank you.
You taking questions?
Oh yeah. Any questions?
Yeah. 3 degrees of freedom, or just 2?
I think mainly it's just 2, so you kind of have the up-down. Often people with Parkinson's, they don't really have kind of a rotational twitch. It's more up and down to the side, so you end up using more of a 2-axis.
Okay, so you looked at that already.
Yeah. Yeah. So that, with that in mind, it ends up reducing the cost. You don't need to program 3 motors. You only have 2 motors, so then the cost goes down for that. So.
How much did you sell your gimbal for if I wanted to buy one?
Don't really know yet. Don't really know yet. How much would we be willing to pay? That's the real question. Rob?
If I were to give you $1 million I don't have, how much of the company would I get? Someone home.
Maybe you get half of it, quarter of it. I don't know, something like that. But
do you know someone with Parkinson's, or how are you inspired by that?
There was one day where there wasn't really a direct inspiration, but I've seen people with Parkinson's who were eating at cafes or drinking coffee. There was one time I was on an airplane ride, and there was someone next to me who had Parkinson's, and they weren't able to drink their cup of soda they were given, and that was just really alarming. That such a simple task would be, I guess, such a difficulty to some of those certain select group of people. I think like with something like this, just creating a device, a simple device that they'd be able to carry in their pocket, is something that can make these everyday challenges